While you are fast asleep, you are probably unaware that Russia and China are launching new space weapons to destroy US satellites. Both countries have been experimenting and deploying new hypersonic missiles capable of wreaking mayhem on the United States. The United States has had enough and is preparing to bring out the big guns to show them who's boss in the intercontinental power tussle. The Russian anti-satellite weapon, known as Nudol, is fitted with high explosive and nuclear warheads, capable of shooting down satellites in near orbit. The missile totally destroyed the Kosmos 1408 satellite on November 15, 2021. The Kinzhal missile, another supersonic weapon in the Kremlin's arsenal, was fired at multiple military facilities during the first month of Russia's invasion of Ukraine. The unstoppable Kinzhal missiles at 5 times the speed of sound, and even President Biden asserted that, quote, "it is almost impossible to stop it." China's anti-satellite weapon is 5 times faster and significantly larger than the Kinzhal. This powerful space weapon is known as the Fractional Orbital Bombardment System, or FOBS. China's Fractional Orbital Bombardment System is a nuclear-armed missile or spacecraft equipped with a warhead that is launched into low orbit and can be guided anywhere on the Earth to bombast a target. China would actually gain a strategic advantage from the development of glider FOBS missiles due to their greater range and incredible hypersonic speeds, rendering them virtually impervious to anti-ballistic defense systems. To say the least, reports of China testing the new FOBS missile system caught the United States off guard. This served as a wake-up call to Washington. FOBS was first deployed during the Cold War era. Even though fractional orbital bombardment systems are not a novel invention, if rumors of the test are true, China would be the first country to have this enhanced capacity. The system involves launching a weapon into low Earth orbit aboard a shuttle with the warhead as its payload instead of a capsule. The weaponized spacecraft continues to circle the Earth's orbit until it's close to its target, and an integrated retro rocket fire deorbiting the warhead and enables it to penetrate the atmosphere at its top Mach 27 and kamikaze its target. The United States can be attacked by the fractional orbital bombardment systems from any direction, obliterating its target 10 times faster than just about any intercontinental ballistic missile. The FOBS is also dangerously agile and intelligent, as it can maneuver away and evade anti-missile defense systems on its way to the target. This is made possible by a glider, which boosts the capabilities of this missile by allowing operators to steer the warhead laterally and vertically towards its target after it re-enters the Earth's atmosphere, thereby making it more difficult to track and shoot down. The missile system's remarkable speed, intelligence, and agility make it highly unpredictable, leaving the US little time to counter the attack between when it is detected and when it kamikazes on US soil. And this would have been the case if the United States was still stuck using its outdated defense systems, which thankfully is not the case. The United States is aggressively keeping up with these countries' space military advancements and countering with a sophisticated and inventive defense system that looks like a sci-fi technology right out of a Marvel movie. Fleets of satellites, billions of dollars, and a global team of experts. The United States is responding with a constellation of deadly military satellites. This satellite fleet will be launched into orbit to track down and disarm hypersonic weapons. The Space Development Agency is heading this project and has announced the award of 2 contracts for this formidable satellite defense system, totaling more than $1.3 billion. So, what does this lethal satellite defense system look like? The system is made up of multiple layers, which would include the custody layer, battle management navigation layer, deterrence layer, and 2 layers of space-based platforms, the transport layer and the T1 tracking layer. The transport layer, which is effectively a communication layer constellation, will deliver assured, durable, low-latency military data and connection to the complete range of warfighter systems globally. It is designed as a constellation of 300 to more than 500 satellites in the low Earth orbit, with a range of 750 to 1,200 kilometers in altitude. With a complete constellation, 95% of the Earth's locations are going to have at least 2 satellites in sight at any point in time, while 99% of the Earth's locations will have at least 1 satellite in sight. The tracking layer, also known as the Tranche 1, is capable of worldwide first missile warning, tracking, indications, and neutralizing advanced missile threats, especially hypersonic missile weapons. It is intended to improve the national defense space architecture's warfighting capacity. This capacity includes both space-based sensors and algorithms, innovative processing techniques, data fusion spanning sensing devices and orbiting modes, and tactical intelligence products that can be sent to the right user. The tracking layer satellites from SDA should be able to detect targets more accurately than conventional DoD missile defense satellite systems in geostationary orbit circling 22,000 miles above the equator. The current space-based early warning capabilities of the United States military are provided by a very limited number of large satellites, such as the Space-Based Infrared Systems fleet. The existing space-based infrared system offers global missile warning and is capable of detecting short-range and intercontinental ballistic missile launches. However, they are not advanced enough to handle sophisticated maneuvering missiles such as hypersonic glide weapon systems. The first of these satellites will be launched by April 2025. In the latest milestone of this project, the Space Development Agency revealed that it had contracted Northrop Grumman and L3 Harris Technologies to develop 14 missile tracking satellites for the tracking layer constellation in low Earth orbit. L3 Harris was awarded a $700 million contract, while Northrop Grumman was awarded a $617 million contract for SDA's tracking layer Tranche 1. The contracts stipulate that each firm will design and build a space segment comprising 2 planes and 7 space vehicles for each plane. This amounts to 14 satellites from each contractor for a total of 28 satellites and 4 planes. These initial satellites are responsible for gathering infrared data and transmitting network communications. Each deal contains a launch services component for launch preparation as well as a ground section for operations and maintenance. The 28 satellites will be sent into low Earth orbit in 4 separate launches of 7 per launch. Each of these satellites will be positioned in a polar orbit, covering our entire planet from north to south. However, they will be on 4 separate planes or hemispheres across the globe. This is the reason why it will require 4 launches to deploy them. The 28 infrared detecting satellites will form part of a worldwide network of sky-watching eyes designed to identify and target the next generation of hypersonic and ballistic missiles currently under development by countries such as Russia and China. In light of concerns that the current defense systems would not be capable of identifying low-flying hypersonic missiles, the Pentagon has made developing a system of infrared detection satellites in low Earth orbit one of its top priorities. The T1 tracking layer effort is a critical step toward building the national defense space architecture. SDA is confident that the selection of the L3 Harris and Northrop Grumman teams provides the best overall solution to accelerate delivery of a low Earth orbit constellation with wide field of view infrared sensors for a global missile warning and missile tracking capability in Tranche 1 on schedule. I'm pleased to see our industry partners building the marketplace necessary to quickly deliver new space capabilities to the warfighter, said Derek Tournier, SDA Director. The data acquired by tracking layer satellites would be relayed to the transport layer through optical connections so that if a missile threat is identified, its position and trajectory data could be safely transmitted via space and downlinked to military command stations. Both tracking and transport layers will be constructed in stages over time, with additional satellites purchased every 2 years. The tracking layer's upcoming Tranche 2 is projected to comprise 54 satellites. However, the T1 is not the SDA's first satellite defense project. In 2020, the SDA ordered the tracking layer's first 8 satellites, also known as Tranche 0, from L3 Harris and SpaceX. The first 2 Tranche 0 satellites will be launched in 2023. The Tranche 1 tracking layer will improve on the Tranche 0 tracking layer capacities with targeted technological advancements, extended coverage, increased integration, developed calibration procedures, and increased manufacturing efficiency. The tracking layer's primary objective is to develop a global network of infrared missile tracking and missile warning systems that will consolidate the transport layer's low-latency mesh communication system, making it possible for traditional and advanced missile detection from the burgeoning low Earth orbit. The Tranche 1 tracking layer satellites will be launched from SDA's Operations and Integration Center situated at Grand Forks Air Force Base in North Dakota and Redstone Arsenal in Alabama. The fact that these technologies are currently on the horizon demonstrates how swiftly the US military is changing course on its space-based missile warning and defense strategy. To show you just how serious the US is about these threats, Congress allocated $550 million in additional funds to SDA in the fiscal year of 2022 to hasten the development and deployment of the tracking layer, with an explicit mandate to exhibit a space-based missile tracking, warning, and targeting system in support of the United States Indo-Pacific Command. The NDSA vision involves developing a system that provides all military commands with a robust global capability as quickly and economically as possible. Northrop Grumman brings decades of proven experience in missile detection, identification, tracking, and communication systems. We look forward to working with the Space Development Agency and our industry partners on the nation's most pressing challenges in missile defense, said Robert Fleming, Northrop's Vice President and General Manager of the Strategic Space Systems Division. The Tranche 1 tracking layer solicitation was released by SDA on March 17, 2022, just 2 days after the President passed the fiscal year 2022 budgetary bill into law. SDA executed a competitive supplier selection and finalized the contracts within 4 months of the issued solicitation by utilizing other transaction authority. The speed with which SDA pursued this effort is commendable, given the severity of the hypersonic missile threat. This prime contract is a testament to our growing impact in the space community and affirms our strategy of being a trusted disruptor in gaining traction, said Christopher E. Kubasik, L3 Harris Chair and Chief Executive Officer. What do you think about Russia abandoning the ISS and building a new space station?